So sorry for the interruption. What happens is I have this software which can allow me to do only for 15 minutes and it stops abruptly. If I don't look at the clock, it stops abruptly, and that's where the problem comes. But I'm trying to make sure that I cover whatever I do in the last few seconds so that it will be a continuity. So this is a continuation of my previous video. What we were talking about is basically antivirus and anti-spyware software. And let me make this a little bigger. So this antivirus and anti-spyware software, they check the computers for presence of malicious software and eliminate them as well. But the problem with this is it requires continual updating. Why? That is because you have lots and lots of new viruses that comes up, as well as lots and lots of systems that needs to be updated. So as we update all these patches, and all that comes from Microsoft, as we update our computers every day, you also need to update the software for protecting them. And that's the reason you need to update, you need to continually update. So when you see something coming up on the side, on the computer, it says update. Don't neglect that, because it is essential for you to make sure that you can continuously work with your computers and work on that, without any interruption. And these, there is also another systems called Unified Threat Management Systems. These are actually small. These are softwares which are coming up, or some of them have already come up, but it is still it's not fully matured, like antivirus or anti-spyware. So it basically is this. Every company, every Silicon Valley company is actually looking for a holy grail of security, because that's where they can make the money, right? Because if you can come up with a fantastic security, then you're going to you're going to be the biggest company in the world. So the holy grail of information security is still to be there. It's not yet come. Okay. Then you have securities for web and for WPA. So WEP, basically is it's a synonym for, it's an abbreviation for wired equivalency privacy, and WPA is an abbreviation for wireless protected access. Okay. So what is the difference between these two? The difference basically is the advanced algorithms. Okay, that is a basic difference. WEP, basically, or WPEP, is a little older one, and WPA2 is a newer version. Okay, so the WPA2 uses advanced algorithms, and the WEP basically uses some older algorithms. There is also another one, there is also another one called WPA, and then there is a WPA2. Okay, there are two different ones, and these two different ones are basically, WPA2 has got, it's newer, and it has got advanced algorithms. Okay. Encryption is something that many softwares are trying to get to. Your emails can be encrypted, that you would have heard about that. So what does this encryption means? So encryption is something that you do, or a computer does, to make sure that an intruder does not understand what is being sent. So for instance, if I send you an email saying yes, yes, that's all, nothing else. Okay. And it is still unclear to anybody, so why I'm saying yes. But let's say I'm saying, so that is not encryption. Encryption is that if I say yes, I convert this S to maybe a number, maybe 563 or something like that. And then you can interpret this 563 to become YES. So the computer turns the S or converts the S to 563. That is encryption. And the 563 is converted back to S, that is decryption. So the encryption and decryption works with what are called keys. And these keys are different algorithms use these many algorithms are there, and these algorithms actually can help you to convert these texts to something so that it is encrypted, and that something can be decrypted to what was the original text. Okay, there are two methods of encryption which is pretty much used. One is the secure socket layer, that is an encryption, and also the transport layer security, TLS. The secure hypertext transfer protocol, which is SHTTP. So all these are pretty much these are encryption. So when you say HTTP colon www something, that is not encrypted, that is not secure. But if you see HTTPS colon www something, then this S basically tells you that it is secured. That is the secured socket layer. Okay, and that basically tells you that it is the site is secured and it is encrypted. Encryption also has got two different types of encryption. One is the symmetric key encryption, another one is a public key encryption. So the symmetric key encryption basically has got a single shareable key. Both the sender and the receiver use a single shareable key. Whereas in a public key, there are two keys. One is called a public key, another one is called a private key. So sender will encrypt a message with a public key, and the recipient decrypts that public key, that is they decrypts that whole message using their private key. Okay. So the sender encrypts with the public key, and the scrambled message or encrypted message is sent to a person who receives it, and the person who receives it decrypts that with a private key. So this public key and the private key works in tandem. Okay, they work together. Then there is another technology which is used called digital certificate. Digital certificate is used to establish the identity of users and electronic assets for protection of online transactions. So usually what you have a certification authority called CA. This certification authority, VeriSign is a certificate authority. Entrust is a certificate authority. These are certificate authorities throughout United States. And what they do is basically they validate any user's identity. Okay, so basically what happens is this: when you go to internet and you want some information, your computer actually gets a certification that is current. Unless that certification is current, you won't get the current data. Okay, so the certification authority basically makes sure that the user's identity is certified, and then it gives you the information. It lets you to go to the party where you, or go to the computer where you can get the information. Okay. So basically, the certification authority verifies the user's identity. It stores the information in their server, and then this digital certificate is generated. It contains the owner's ID information and also the public key, and that is sent to a computer. Okay, so you can see this digital certificate in any type of a computer transaction, basically. I was trying to show you the certification authority, but the problem is that I can show that on Internet Explorer or Safari and things like that, or even in Google Chrome. But I'm using Microsoft Edge, and Microsoft Edge does not show the certificates. That's a problem. But basically, a certificate it looks like long numbers. It is something like uh, 0 0 4 2 3 1 6 1 7 8 p 6 9 7 8 21 4G, those kind of things. This is how a certificate actually looks. And if you can go to Google Chrome, if you have a Google Chrome or if you have Internet Explorer, you can actually go and click on the right bar, on the top bar, on the right click, and go to see you can click on that padlock, which is like a golden padlock which says HTTPS. You can click on that and you should be able to check it out. Okay. But anyways, so that's where the digital certificates are. Public key infrastructure uses a public key cryptography. This cryptography basically is a science, and it has got a lot of math in it, and it pretty much gives you certain algorithms and certain ways to encrypt. And it is very mathematically oriented. There are lots and lots of different cryptography, digital way of encrypting things. And these different algorithms in the cryptography people are actually coming up with newer and newer algorithms to make it tougher and tougher for people to decrypt other than the intended person. Okay, it is pretty much used in e-commerce. These are public key. PKI is pretty much used in e-commerce. So digital certificates. If you take if you have an individual subject or a computer, it requests the first thing it does is to request a certificate. It goes through the internet to the certification authorities, which is located in California or Texas somewhere, and then that certification authorities will send you the certificate back into this computer. It takes less than a millisecond for that. The certificate is received. The certificate actually has got a digital serial number, issuer name, date, expiration date, the public key, the signature of the certification authority, and other information basically. Okay, this is how it works. So anytime you go through the internet, this is done. So anytime you want to access a computer, access for information, this happens. So your computer gets delivered a digital certificate to make sure that everything is gung-ho and everything is good. Okay. System availability is very important. You want every company, every firm, every place wants 100% availability. And online transaction processing for sure requires 100% availability. For instance, Amazon, you need Amazon all the time. It should be on all the time. So anybody can pretty much go to Amazon and order something anytime, 24/7, 365 days, or 366 days if it is a leap year. And so these systems availability is done using what are called fault-tolerant computer systems, which are basically redundant computer systems. So you need to have 2 or 3 or 4 different computer systems which replicates each one of them. So every computer, every database is replicated twice or thrice, so that if one fails, something will take over, basically. So that you'll have an uninterrupted service. Okay. The next thing is that when you talk about information security, you also talk about ensuring software quality also. Okay, so ensuring software quality basically makes sure that everything is really good and it is debugged and there is no bugs and things like that in the software. The quality is really good and all that good stuff. Okay.